Assalamu alaikum. I am Utsav Shaha, ID 84, presenting the project of Group 2, Design of Automated Traffic Control with RGB LEDs and only digital logic circuits. The other group member for these projects are ID 72, 85, 88 and 89. In today's world, traffic control is a major concern. One of the primary issues for densely populated city like Dhaka is traffic congestion, which occurs when the population and the number of running vehicles exceeds the city capacity. Traffic management in Dhaka is likewise a difficult task, and physical efforts alone will not suffice to solve the problem. We require a dynamic system to control traffic smoothly, and such a system is known as automatic traffic control system. We have several features for this project. Among them, some key features are traffic light of each junction with red, yellow and green has been implemented. Pedestrian crossing for each road has been defined. Pedestrians are guided with red and white light. These are the necessary elements that we have used for our project. This is the map of TST Chattor that has been made using cork sheet, traffic modules, colorful papers and LEDs. Now we are presenting the circuit diagram that we implemented for our project. Now we will show the manual control of our traffic signal project. Now here we go. First of all, we stop the input to the 555 timer. Now we are going to push this push button. We can see with every push the countdown is happening. Also the sequence of the traffic light signal is also changing. Here we can see with the bigger picture. Now the red light in the first signal is gone and the timer is off. When the red signal is on again, the countdown starts again.
I am Rajnindra Roya, role 88. Now we will put our attention to the traffic light signals of the project. Here there are 4 traffic light signals, each consisting of red, yellow and green light, also a white and a red light for pedestrian. Here, for implementing the logic of the white and red light for pedestrian, we have used the fact that when all the red lights in all 4 signals are on, then the pedestrian white light will be on, otherwise the pedestrian red light will be on.
Now we will see the display part. Here for controlling the 4029 decade counters, we have implemented 2 logic circuits. And the output of these counters are termed as preset 1 and preset 2. The upper and lower 7-segment displays are for unit and decade points respectively. Now we are going to run this project. The display will follow the lights of the first signal. Here we can see that all 4 lights are red. So the pedestrian light white LED is on. After this set of pulse, the first signal with red light enable the countdown of the remaining time of the red signal of the signal 1. Here we can see that all the 4 signals are automatically receive pulse and change their state after some set of time.
Control mechanism of traffic lights. Name Mohammad Ahmed Kabir, ID 1706072. 555 timer, first and second 4017 decade counter. For pulse generation, we have used a 555 timer and 2 decade counters are cascaded for ring counting. The first one have control over 1 cycle of the traffic light sequences wireless. The second counter acts as an outer loop for running the whole traffic signal operation 4 times. The total traffic cycle has 40 steps, as 10 from the first counter into 4 from the second counter. Generation of pins to drive the traffic lights. Here pin 1, 2, 3, 4, 5 are OR gated to create step 1 pin indicating green light. Pin 6 is used as step 2 pin indicating yellow. Pin 7, 8, 9, 10 are OR gated to constitute step 3 pin indicating the red light. Logical approach for creating the control circuit. We have divided the whole system into 4 cycles. Here the square matrix for the traffic light sequences is shown. The matrix has characteristic traffic sequence along the diagonal. The sequence GYRR is unique to each of the signal when their respective cycle comes. Another important feature in this matrix is that, or is the fact that each signal shows only red in the cycles except their own. Therefore, if For example, cycle 234 pin are OR gated that will create a pin for driving the red LED of signal 1. The same is true for all other red signals. To get GYRR light in the duration of cycle 1 for signal 1, step 1, 2, 3 pins are AND gated with cycle 1 pin respectively. At the end of the row of signal 1, the yellow light before the green can be driven by AND operation of cycle 4 and pin 10 as it is the last pin of the first decade counter for a cycle. The yellow LED of signal 1 at cycle 1 and cycle 4 are OR gated to get a common yellow LED driving pin. Likewise, the red light of cycle 234 and the red light of cycle 1 for signal 1 are OR gated for getting a common pin for red LED in signal 1.
Hello, I'm Ishtiaq Hassan Arnab, ID 89. So today we are presenting a digital electronic project laboratory project named by four-way traffic light control mechanism with pedestrian passing management. Here we are assigned the location named TSC Chottor. It constitutes a four-way traffic control. So we have implemented 4 traffic signals.
Our sequence for traffic signal is red, yellow, green, yellow, red. The first yellow is for preparation of stopping and the second yellow is for preparation of moving. We have also successfully implemented lights with different durations. Red and green are staying longer in time than yellow. We have implemented 2-digit display where the display is synced with the first signal. The first signal is at Shamsun Nahar Road. The second signal is at Sohrawardi Uddan Road. The third signal is at Kazi Nazrul Islam Avenue and the fourth signal is at Nilkhet Road.
I am Redul Mahmood Talukdar. My ID is 85. Here in our project, we have 3 traffic lights for the car movement and there are 2 lights, white and red, for the pedestrian movement. Here is also our countdown display circuit, which will be implemented for the first signal, which is Shamsun Nahar Road. Our project showdown will be perfect if we turn off the light. Here, as the first signal is red, the countdown starts from 34. And at that time, all the pedestrians can move safely as the pedestrian signal is white. Now, in the Sohrawardi Uddan Road, the signal is green, so the cars can pass. After some time, it will be yellow for the drivers preparing to stop. And then it will be red. And this time, the pedestrians can move safely as all the traffic signals are red and pedestrian signal is white. Now, in Kazi Nazrul Islam Avenue, the green signal will be on. At that time, the pedestrians cannot move as the pedestrian signal is red. And it will be yellow, then red. Again, in Nilkhet Road, the signal is red, then yellow for preparing to stop, and then green. At that time, the pedestrian signal is red, and you can see the countdown clock display is synced with the first signal. As it is red, it is countdown from 5. Now the first signal will be yellow and then green, and the countdown is stopped.
My name is Mohammad Tahmid Kabir, ID 72. Now we are going to show the conversion from auto control to manual control. First of all, we need to switch on. The 555 timer is switched on. We need to switch off the source of the 555 timer, and then we need to switch off the clock input to the 4017 decade counter. Then we are going to push the push button. Here you can see at every push, the sequence of the signal system is changing, and also at every push, the remaining time of the red signal in the first road, that means the Shamsun Nahar Road, is also changing, and it is perfectly synced to the first signal. Now we are going to revert back to the auto control from manual control. First of all, we need to switch on the clock input into the 4017 decade counter, and then switch on the source of the 555 timer. Here you can see without any push button, the sequence of the traffic signal lights are auto-tuned and automatically counting down the timer of the red signal.
Emergency control of traffic signals, VIP vehicle, ambulance, and fire brigade vehicle. First, we have created 5 logic switch circuit for forced high and low state of the input pin to green signal and enable pin of 4017 decade counter. V1, 2, 3, 4 pins are OR-gated respectively with green LED driving pins. For forced high and low state of the red LED input pins, VR1, 2, 3, 4 have been implemented. Associated problems with 4017 decade counter in Proteus. For Proteus simulation, 4017 decade counter has hidden pins VCC and VSS, which cannot be controlled, and the VCC is always high when the simulation is run. Therefore, any of the pin is purported to be high and is latched with a state, and even if we go to manual control, this latched condition cannot be eliminated. Though our approach can force GRRR state to any of the forced signal, but due to latched condition not being eliminated, we could not switch off the last state of the traffic sequence. For example, we try to forcibly input green light at signal 2 due to emergency. At a moment's notice, the green light at signal 2 is present and signal 1, 3, 4 are red light, but the excess red light at signal 2 and green light at signal 3 are coming from the previous latch state. Thank you all.